June 7, 1944, Omaha Beach, Normandy. Private First Class Robert Sales crouches behind a disabled Sherman tank trying to make himself as small as possible, while the distinctive sound that every American soldier will learn to fear echoes across the beach, a sound like ripping canvas or a buzzsaw tearing through metal, so fast that individual shots blur into a continuous roar that seems to come from everywhere at once. The sound is a German MG42 machine gun firing from a concrete bunker on the bluff above the beach, and Sales watches in horror as the stream of tracers, visible even in daylight because the rate of fire is so high, sweeps across a group of soldiers attempting to advance up the beach, and men fall in clusters as the bullets find them faster than they can react or take cover. Sales has trained extensively with American machine guns, including the Browning M1917, water-cooled, and M19 air-cooled weapons that provide sustained fire support for infantry operations, and he's confident in these weapons' reliability and effectiveness based on what his instructors taught him during training stateside. But nothing in that training prepared him for the psychological impact of facing the MG42, which fires so fast that taking cover feels futile, because by the time you hear the gun firing, dozens of bullets have already passed through the space you occupied. The rate of fire is so high that American soldiers initially think they're facing multiple machine guns firing simultaneously, and it takes several encounters before they understand that the continuous roar comes from a single weapon firing at speeds that exceed anything in the American arsenal. The MG42 that's pinning down Sales and hundreds of other American soldiers on Omaha Beach is the Maschinengewehr 42, the standard German machine gun that entered service in 1942 and which represents the culmination of German thinking about how infantry machine guns should function in modern warfare. The weapon fires 7.92 mm Mauser ammunition at a rate of approximately 1/200 rounds per minute, 20 rounds per second, which is nearly 3 times faster than the Browning M19's rate of 400 to 500 rounds per minute. And this enormous difference in cyclic rate creates tactical effects that German forces exploit ruthlessly, and which American forces struggle to counter, because their doctrines and training haven't prepared them for facing suppressive fire of this intensity. The psychological effect of the MG42's high rate of fire on American infantry is profound and immediate, and soldiers who survive their first encounters with the weapon consistently report that the sound alone is terrifying in ways that slower firing weapons are not, because the continuous roar creates the impression of an impenetrable wall of bullets that cannot be crossed or survived. American infantry tactics developed around the Browning machine gun assume that soldiers can identify when the gun is firing, estimate the beaten zone where bullets are impacting, and maneuver around or through that zone during brief pauses when the gun isn't firing. But the MG42's sustained high rate of fire means there are no pauses long enough to exploit, and attempting to advance against an MG42 position requires levels of courage bordering on suicidal, because soldiers know they're advancing into fire that will kill them almost instantly if they're caught in the open. The capture of intact MG42 weapons begins almost immediately after American forces secure their beachheads in Normandy, and intelligence officers who understand the value of examining enemy equipment make capturing MG42s a priority, because frontline reports from infantry officers consistently describe the weapon's devastating effectiveness and request information about its vulnerabilities and how American forces might counter it. By late June 1944, several intact MG42s had been captured along with ammunition, spare barrels, and even some of the German soldiers who operated them. and these weapons are shipped back to Aberdeen Proving Ground in Maryland, where American ordnance experts can conduct the systematic examination and testing needed to understand exactly how the MG42 achieves its extraordinary rate of fire and what implications this has for American small arms development. The examination team assembled at Aberdeen includes weapons designers from Springfield Armory and other facilities involved in small arms development, ordnance officers with combat experience who can provide context about how the weapon is employed tactically, metallurgists who can analyze the steel composition and manufacturing techniques, and military observers who will assess whether American forces need similar weapons and how quickly they could be developed and fielded. These experts approach the examination with a mixture of professional curiosity and genuine concern, because the MG42 represents a significant tactical challenge that American forces are confronting daily in Normandy. And understanding the weapon's design and developing effective countermeasures could save American lives. The first detailed inspection of an intact MG42 reveals a weapon that is fundamentally different from American machine gun designs in almost every aspect of its construction and operation, and American ordnance experts are immediately struck by how the weapon achieves high performance through design innovations rather than through precision manufacturing or expensive materials. The MG42 is constructed primarily from stamped sheet metal components that are welded together rather than being machined from solid steel billets like American weapons. And this stamped construction allows rapid production using relatively crude manufacturing equipment and semi-skilled workers, which explains how Germany can produce MG42s in enormous quantities despite the bombing campaign that's disrupting German industry. The operating mechanism that gives the MG42 its extraordinary rate of fire is examined carefully, and American weapons designers discover that the gun uses a short recoil operation with a rotating bolt that locks and unlocks very quickly, and the recoil spring is calibrated to cycle the action at maximum speed while still maintaining reliability. The bolt carrier and bolt assembly are designed to minimize reciprocating mass, the weight of parts that move back and forth during firing, which allows faster cycling because lighter parts can be accelerated and decelerated more quickly than heavier parts. And every component shows evidence of careful optimization to eliminate unnecessary weight while maintaining structural integrity sufficient for the weapon's operational requirements. When American test crews fire the captured MG42 on the Aberdeen Proving Ground ranges, they confirm that the weapon's rate of fire is indeed approximately 1,200 rounds per minute, as combat reports indicated, and this sustained high rate of fire produces effects that are qualitatively different from American machine guns firing at 400 to 500 rounds per minute. At the higher rate, the stream of bullets is so dense that beaten zones, the areas where bullets impact, overlap substantially, and any target caught in the MG42's fire receives multiple hits almost simultaneously rather than being struck by individual bullets with gaps between them. American testers find that when firing at targets representing infantry soldiers, the MG42 consistently delivers 3 to 4 hits for every 1 hit that a Browning M1919 delivers in the same time period, and these multiple simultaneous hits are far more likely to incapacitate or kill than single hits. The barrel change system on the MG42 is examined and proves to be one of the weapon's most innovative features, allowing a trained crew to swap a hot barrel for a cool one in approximately 5 seconds without tools and without requiring the gun to be removed from its mount or position. The barrel is held in place by a latch mechanism at the rear of the receiver, and changing barrels requires simply opening the latch, pulling the hot barrel forward out of the receiver, inserting a cool barrel, and closing the latch. And American ordnance experts recognize immediately that this quick change capability provides enormous tactical advantages, because sustained fire from machine guns inevitably heats barrels to temperatures where accuracy degrades and barrel life is shortened. And the ability to change barrels quickly means that MG42 crews can maintain sustained fire indefinitely by rotating through multiple barrels as each one becomes too hot. American machine guns use barrel change systems that are slower and more cumbersome, with the M1917 water-cooled gun requiring approximately 2 minutes to change barrels because the water jacket must be drained, removed, the hot barrel unscrewed, a cool barrel screwed in, and the water jacket reinstalled and refilled, and even the air-cooled M1919 requires unscrewing the barrel using a special tool and careful handling, because the hot barrel can burn crews who touch it. The MG42's quick-change barrel system means that German crews can maintain much higher sustained rates of fire than American crews, because they can change barrels before they overheat, rather than having to wait for barrels to cool or risk damage from firing overheated barrels. The ammunition feed system is examined and found to use non-disintegrating metal link belts that can be connected together to create belts of any length. And this system allows German crews to prepare long belts in advance and feed them continuously into the gun without pauses to reload. While American machine guns typically use fabric belts or metal link belts that must be loaded into the gun in fixed length segments. The MG42's belt system also uses a clever feed mechanism that prevents double feeding or jams even when ammunition quality varies, and American testers find that the weapon will function reliably even with ammunition that's slightly out of specification or damaged, which indicates that German designers prioritized reliability under field conditions over precision fit that requires perfect ammunition. The examination of the MG42's construction reveals extensive use of manufacturing techniques that American ordnance experts initially consider crude, but gradually recognize as sophisticated methods for achieving adequate performance with minimal machining. And the stamped sheet metal receiver that American examiners initially dismiss as flimsy proves to be adequately strong for the weapon's operational requirements, while being far faster to produce than machined receivers. The spot welds that join sheet metal components are examined and found to be strong enough despite being made quickly by semi-skilled workers, and the overall construction demonstrates that German designers understood how to achieve functional adequacy through intelligent design rather than through expensive materials or precision manufacturing. American metallurgists analyze samples of the MG42's barrel steel and find that the composition and heat treatment are appropriate for a machine gun barrel that will experience high temperatures and rapid firing. And while the steel quality is somewhat variable, suggesting that German steel production is under stress from Allied bombing and resource shortages, the average quality is sufficient for the weapon to function reliably for its expected service life. The barrel's rifling is examined and found to be adequately precise for accuracy at machine gun engagement ranges, and American experts note that German manufacturers are achieving acceptable barrel quality using simpler manufacturing processes than American barrel production typically employs. When American infantrymen who have combat experience against the MG42 are brought in to observe the testing and provide their perspectives on the weapon's tactical employment, they consistently emphasize the weapon's psychological impact and its effectiveness in area denial and suppression. explaining that the MG42's high rate of fire makes crossing open ground under its fire feel impossible because soldiers know that any movement will be met with dozens of bullets arriving almost simultaneously. The infantrymen describe how German forces employ the MG42 as the centerpiece of defensive positions, with riflemen positioned to cover areas that the machine gun cannot effectively engage, and they explain that American infantry tactics that work against slower-firing machine guns are far less effective against the MG42 because there aren't pauses in the fire that can be exploited for movement. The testing program includes comparative evaluations where the MG42 is tested alongside American machine guns, including the M1917, M1919, and the newer M1919A6 variant. And these direct comparisons reveal the magnitude of the performance gap in sustained fire capabilities. When both weapons are fired at the same target array simulating infantry soldiers advancing across open ground, the MG42 consistently achieves 3 to 4 times as many hits as the Browning weapons in the same time period, and the density of fire is such that targets in the MG42's beaten zone receive multiple hits, while targets engaged by the Browning weapons often receive only one hit or none. American ordnance experts calculate that a German squad equipped with one MG42 can deliver suppressive fire equivalent to 3 American squads equipped with M1919 machine guns, and this 3-to-1 effectiveness ratio has profound implications for force ratios and tactical doctrine. The examination also includes careful study of German tactical doctrine for employing the MG42 based on captured training manuals and interrogation of German prisoners who served as machine gunners. And American analysts discover that German infantry tactics treat the machine gun as the primary weapon around which the squad is organized, with riflemen serving primarily to protect the machine gun and exploit the suppression it creates rather than being the primary source of firepower. This doctrine is fundamentally different from American infantry organization, where the rifle squad is the basic unit and machine guns are supporting weapons, and the German approach reflects their understanding that the MG42's high rate of fire makes it far more effective at suppressing enemy infantry than rifles can be. American ordnance experts examining the MG42 gradually realize that the weapon represents not just a technological achievement, but a coherent philosophy about how infantry combat should be conducted, with German forces apparently concluding that suppressive fire delivered at high volume is more valuable than accurate aimed fire from individual riflemen, and that organizing infantry squads around a weapon capable of delivering overwhelming suppressive fire provides tactical advantages that justify accepting the ammunition consumption and logistical burden that high rate of fire weapons require. The MG42 consumes ammunition at rates that American logistics officers find alarming. A single gun firing for 1 minute at maximum rate will expend 200 rounds weighing approximately 30 kilograms. But German forces apparently accept this consumption as worthwhile because the suppressive effect prevents enemy infantry from effectively returning fire or maneuvering. The psychological effect of the MG42's distinctive sound is analyzed, and American experts confirm what infantrymen report, that the weapon's rapid fire creates a continuous roar that is far more intimidating than the slower, more rhythmic sound of American machine guns, and this psychological impact contributes to the weapon's effectiveness in suppression, because soldiers under MG42 fire are more likely to remain in cover and less likely to attempt movement or return fire. Some American analysts suggest that the MG42's designers may have deliberately optimized the rate of fire partly for psychological effect, choosing a cyclic rate high enough that individual shots blur into continuous noise, and whether this was intentional or simply a byproduct of pursuing maximum rate of fire, the psychological impact is undeniable. The reliability testing conducted at Aberdeen reveals that the MG42 is remarkably robust and will continue functioning under conditions that would cause American machine guns to jam or fail, and testers deliberately subject the weapon to abuse, including firing it while covered in mud, dunking it in water, and firing it without cleaning for thousands of rounds, and the MG42 continues operating reliably through all these tests. The weapon's design incorporates generous clearances between moving parts that allow dirt and debris to pass through without causing jams. The bolt and receiver are designed to be self-cleaning with carbon deposits and fouling being blown out during firing. And the overall design demonstrates that German engineers prioritized field reliability over precision fit and close tolerances. American weapons designers analyzing the MG42 recognized that several of its innovative features could be incorporated into American machine gun designs to improve performance, and discussion begins about whether the United States should develop a new general-purpose machine gun incorporating lessons learned from examining the MG42. The quick-change barrel system is identified as particularly valuable and something that American weapons should adopt. The stamped metal construction is recognized as allowing faster production, though American manufacturers would need to develop new tooling and processes to implement it. And the overall design philosophy of prioritizing high rate of fire and sustained firing capability over weight and complexity is acknowledged as having merit for certain tactical applications. However, American ordnance officials also recognize significant challenges in adopting MG42-inspired designs, including the enormous ammunition consumption that high-rate-of-fire weapons require, the logistical burden of supplying enough ammunition to support these weapons in sustained combat, and the training requirements for crews who must manage barrel changes and ammunition supply more actively than crews of slower-firing weapons. American infantry doctrine is built around the rifle squad, with machine guns providing support, and adopting German-style tactics centered on the machine gun would require fundamental reorganization and retraining that cannot be accomplished quickly during wartime. The examination of captured MG42 ammunition reveals that German forces use standard 7.92mm Mauser cartridges that are identical to rifle ammunition, except for some lots being loaded with tracer bullets or armor-piercing projectiles for specific applications. And this commonality between rifle and machine gun ammunition simplifies German logistics because a single ammunition type serves both rifles and machine guns. American forces use different calibers for rifles, .30-06, and some machine guns, .50 caliber. And while the .30-06 cartridge is used in both the M1 Garand rifle and the Browning machine guns, the existence of multiple cartridge types in the American inventory adds complexity that the German system avoids. The MG42's effectiveness in defensive positions is analyzed based on combat reports from Normandy and subsequent operations, and American intelligence officers compile statistics showing that German defensive positions anchored by MG42s consistently inflict higher casualties on attacking American forces than positions equipped with older German machine guns or positions that rely primarily on rifle fire. The data suggests that a well-positioned MG42 with adequate ammunition supply and clear fields of fire can hold up an American infantry platoon or even company for extended periods, and that reducing MG42 positions typically requires either flanking maneuvers that expose American forces to fire from other positions, direct fire from tanks or artillery, or close air support, all of which take time to coordinate and execute. American tactical responses to the MG42 threat evolved throughout the Normandy campaign and subsequent operations, with infantry units learning through hard experience that frontal assaults against MG42 positions are prohibitively costly, and the combined arms approaches using tanks, artillery, and air support to suppress or destroy machine gun positions before infantry advance are necessary. American forces also learned to prioritize capturing or destroying MG42s when overrunning German positions, because allowing crews to withdraw with their weapons means facing the same MG42s again at the next defensive line, and the psychological impact of the weapon makes neutralizing it a high priority even when other tactical objectives might be more important. The examination of the MG42 contributes to post-war American weapons development programs, including the M60 machine gun that enters service in the late 1950s and which incorporates several features inspired by the MG42, including a quick-change barrel system that allows barrel swaps in seconds without tools, a similar operating mechanism using a rotating bolt, and a design philosophy that prioritizes sustained fire capability and field reliability over weight or complexity. The M60 never achieves the MG42's extremely high rate of fire. The M60 fires at approximately 550 rounds per minute compared to the MG42's 200, but it incorporates the lessons about barrel changing and sustained fire that American examination of the MG42 revealed. The broader impact of encountering the MG42 on American infantry doctrine and weapons development is significant because the weapon forces American military thinkers to reconsider assumptions about optimal machine gun characteristics and infantry squad organization. And while American forces don't adopt the German model of centering infantry squads on the machine gun, the recognition that suppressive fire delivered at high volume provides tactical advantages influences how American forces employ machine guns and how much emphasis is placed on providing adequate ammunition supply to sustain high rates of fire. The MG42 also demonstrates that stamped metal, construction, and simplified manufacturing processes can produce weapons that perform adequately or better than precision-machined weapons, and this lesson influences post-war American small arms development, where stamped construction becomes more common. The psychological legacy of the MG42 among American infantrymen who fought in Europe is lasting, with veterans consistently describing the weapon as one of the most fearsome they encountered, and crediting it with inflicting enormous casualties on American forces throughout the European campaign. The distinctive sound of the MG42 becomes permanently associated in veterans' memories with danger and death, and decades after the war, veterans report that hearing similar rapid-fire sounds can trigger intense emotional responses because the sound of the MG42 created such strong psychological conditioning during combat. This psychological impact validates what German designers may have understood intuitively or discovered empirically, that the sound of a weapon can contribute significantly to its tactical effectiveness by influencing enemy behavior and creating fear that degrades combat effectiveness. The story of Americans capturing and examining the MG42 is ultimately a story about how encountering a superior enemy weapon can drive innovation and doctrinal change, about how examination of captured equipment provides insights that intelligence and observation alone cannot deliver, and about how even a mature military force with extensive resources can be surprised by innovative designs that solve old problems in new ways. The MG42 was not the most accurate machine gun, not the lightest, and not the most ammunition efficient, but it was extraordinarily effective at its primary purpose of delivering suppressive fire that prevented enemy infantry from maneuvering or returning effective fire. And German designers' decision to prioritize rate of fire over other characteristics created a weapon that American forces found nearly impossible to counter tactically until they adapted their tactics and developed combined arms responses. The examination of captured MG42s at Aberdeen Proving Ground provided American ordnance experts with detailed understanding of how the weapon achieved its performance and what innovations made it effective. And this knowledge influenced American weapons development for decades after the war ended. The quick-change barrel system, the stamped metal construction, the emphasis on sustained fire capability, and the recognition that suppressive fire delivered at high volume provides tactical advantages all became part of American small arms development thinking. And weapons like the M60 machine gun represent the application of lessons learned from examining the MG42, even though they don't simply copy the German design. The MG42 itself continued in service with German forces through the end of World War II and was so effective that it remained in production in modified forms for decades after the war, with the MG3, essentially an MG42 rechambered for NATO's 7.62mm ammunition, serving as the standard machine gun for the West German Bundeswehr and other NATO forces into the 21st century. This extraordinary longevity demonstrates that the MG42's designers created a weapon that was not just adequate for the specific conditions of World War II, but was fundamentally sound in its approach to machine gun design. And the fact that a weapon designed in the early 1940s remained competitive into the 2000s speaks to the quality of the original design and the innovations it incorporated. For American infantry who faced the MG42 in combat from Normandy through the end of the war, the weapon represented a persistent tactical challenge that required constant vigilance, careful tactics, and combined arm support to overcome, and the examination of captured examples provided at least the satisfaction of understanding how the weapon worked and why it was so effective, even if that understanding didn't make facing it less dangerous. The MG42's high rate of fire, quick-change barrel system, reliable operation under harsh conditions, and devastating suppressive effect made it one of the most effective infantry weapons of World War II, and American examination of captured examples confirmed what frontline soldiers already knew from bitter experience, that the weapon's distinctive buzzing roar meant death for anyone caught in its fire without adequate cover.